A bullet is fired from a rifle whose barrel is 0.84 meters long. The bullet leaves the gun moving 521 meters per second. What is the acceleration of the bullet while it's inside the gun? So we drew the picture. Here's a very poorly drawn gun, but I'm not an artist. The barrel of the gun is 0.84 meters long. Here's where the bullet will start. There's where the bullet will leave the gun. Initially, a bullet inside of a gun before you pull the trigger has no speed, so the initial velocity would be 0, but it's definitely going to get faster, 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 and the acceleration is going to be in the same direction, and that's the thing that we're trying to find. The problem did tell us that as the bullet leaves the gun, it's traveling 521 meters per second. So now we have to pull the numbers out of the problem and out of the picture and put them here in our list of variables. The first thing we definitely know is that from the start of the bullet travels to when it leaves the gun, it's going to travel 0.84 meters. We know that a bullet is not moving before you pull the trigger, so the initial speed of the bullet is 0. We're only interested in the moment the bullet starts being fired till the moment it leaves the gun. That's when it's accelerating. And that means that at the end of its trip, inside of the gun, its final velocity is 521 meters per second. And the question is, what is the acceleration of the bullet inside the gun? We're going to be coming up with the equation that does not have time, because time is a thing we do not care about, and that would be Vf squared equals V naught squared plus 2AD. I don't typically plug in numbers early unless I get a 0 and it's going to make my life easier. In this case, it will, because V naught being 0 means V naught is just going to go away. I don't ultimately care about that because it's gone. That's going to make my math a little bit easier. Vf squared equals 2AD. Trying to solve for A, I can just divide 2 and D over to the other side. So my 2's cancel and my D's cancel. I can plug in some numbers. Vf squared is 521 meters per second squared all over 2 times 0.84 meters. Once we plug in all of these numbers to get A into our calculator, I would be able to find out that the acceleration is going to be 161,572 meters per second squared. You might think that's a big number, but we are talking about a bullet inside of a gun. It should be a big number.